or two topics, whatever topic is, I can clear that. Since other student didn't join and also you haven't revised alcohol, so it won't benefit you basically.
So then can we do electrochemistry or maybe coordination compounds?
Yeah, but what topic? You want introduction of that, basic things, or you want a specific topic?
Sir, and over just introduction would be fine, sir. Just the starting of it and what it is.
Okay, so let me know which chapter. The chapter which you are studying, I think that will be beneficial because you are studying as well. Or
Electrochemistry, sir.
Okay, so in electrochemistry, I would like to introduce some term like there are some topics that you should take care, like electrode potential. You know that, right?
Yes.
ECS. Before that, NOST equation is there. So you want only the introduction, right?
Also, if you have any important topics in mind, then can you take that?
Yeah, we can do that. Daniel cell we are going to do. Because Daniel cell from this we will be able to do this electrode potential and electrode with the help of electrode potential we can do NOST equation. Okay, and with the help of electrode potential what it is we can do ECS as well. Is that clear?
Yes,
Can
sir.
we go for Daniel cell?
Yes, sir.
Let me take a pic of this.
Sir, I apologize, but your voice is very low.
Okay, no problem. I'm just gonna disconnect my mic and again connect it. Just wait a few minutes.
Okay, sir.
Wait a minute. Am I clearly?
So now you're lagging.
Wait a minute. It will be all right. If my voice is still low, I'll just remove the mic.
No, now it's good. Now it's all right.
Okay, so you asked me for Daniel cell, and I'm going to give you this. Yeah, are you there? Yeah, are you there? Razika, can you see the screen?
Yes, sir.
Okay. So this is your Daniel cell, okay? Sophia, there is doubt uh, in Daniel cell for Razika, so I'm going to discuss this.
Sir, what are
So,
we studying today? Sorry, sir, I joined late.
yeah, I was asking, did you revise alcohols?
Did you
Phenols,
revise?
phenols and ethers. This is what basically we completed this alcohols, phenols, ethers questions, but I still gave you this to revise and do some more questions. Okay. So basically today there is a doubt in electrochemistry for Rajita. So I'm going to do this. This is beneficial for you as well because it's a very important topic from electrochemistry. Okay.
Yes, sir.
Okay. So please concentrate. And if you have any doubt in any topic or anything, now you can just make a list and give it to admin. And accordingly, we can schedule the class like 15 or 20 minutes of the last of our class. Like after practicing, we can do that as well. So let's start Daniel cell. Daniel cell. In Daniel cell, there is two compartments: the left compartment and the right compartment. Okay, the right compartment. Now you can see this left compartment has a solution of a salt, that is your ZnSO4, and there is an electrode. You can see there is an electrode which is made up of zinc, which is made up of zinc. And on the right compartment, there is a solution of salt, CuSO4, and this, what do we say? Electrode is made up of copper. CuSO4 solution, and this is made up of copper. This is Daniel cell. Okay. So what happens in this? How the reaction proceeds? Very simple. It is. Okay. So basically, there are. This is a electrochemical cell. What is electrochemical cell? Conversion of chemical energy into electrical energy. Conversion of chemical energy into electrical energy. And this cell, electrochemical cell that we are talking about, electrochemical cell, is conversion of chemical into electrical energy. Is an Daniel cell is an example of this electrochemical cell. And in this cell, a spontaneous redox reaction takes place. So I think a spontaneous, you already know the term spontaneous. That means the process which carries on by itself. This process does not require any external agent. That process is called spontaneous. And redox, you know that a reaction or a process in which oxidation and reduction both involve simultaneously, that is called redox. So first of all, what is electrochemical cell? The cell in which chemical energy is converted into electrical energy. And electrochemical cell is your spontaneous redox reaction. Now see, what will happen? On the left hand side, we have zinc, and this is the rod of zinc, that means electrode. So after connecting this, what will happen? This zinc will be oxidized. That means this zinc electrode, there will be some zinc that will be broken from the that electrode and goes into the solution in the form zinc will be converted into Zn plus 2 electron. Try to understand my point. Like there is a rod of zinc, and rod of zinc, that means that rod is made up of zinc, and this is solution of ZnSO4. So from this rod, Zn will be oxidized into Zn plus 2, and electron will be left in that rod. Just wait a minute. Electron will be left in that rod. Okay. So you can easily see that on the left hand side, oxidation takes place. Left hand side, oxidation takes place. Okay, left hand side oxidation takes place. And by default, by IUPAC, on the left hand side in electrochemical series, we will have electrochemical cell, we will have anode. So whenever we are going to see any electrochemical cell, if it is on the left hand side, it is anode, and at anode oxidation takes place. So after some time, what will happen? The potential, the density of electron on the left hand side increases. The density of electron on the left hand side increases. It's just like there is two tanks. One tank is full of water and one tank is empty. There is no water. And you just connected this tank like this. So what will happen? Basically, the water is more on the left hand side and there is no water or very less water on the right hand side. The water will flow from left to right. In the same way, when zinc started oxidizing itself and goes into the solution, its electron, zinc's electron in the rod increases. That means the electron density on the left hand side increases and starts flowing from anode to cathode. Anode to cathode, just like this water in tanks. Okay, anode to cathode. Since electron is started moving from left to right, the current flows from right to left. Are you getting my point? This is a very conceptual point. They can ask you the direction of current. So the direction of current will be cathode to anode because electron started moving from left to right. That means anode to cathode. Is that clear? Both
Yes.
of you, Rajita and Sriya. Okay. Now see, when electron will reach here, on the right hand side, cathode. Since this is a solution of CuSO4, copper sulfate, and when copper sulfate or ZnSO4, when any salt is present in a solution, it will be in its ions form, like CuSO4. If it is solid, that is okay. But if you are going to put this in water, what will be the scenario? It will convert itself into Cu plus 2 plus SO4 minus. Now in the solution, Cu plus 2 is there, and there are electrons that came from anode to cathode. So as you know that opposite charges attract each other. So this Cu plus 2 goes and stick to the cathode. There is a force of attraction between this plus 2 charge and that electron which is carrying negative charge. You know that electron carries negative charge. So on the right hand side, what happens? On the right hand side, reduction takes place. Reduction takes place, as you know that Cu plus 2 is there, electron it will gain and it will convert itself into Cu solid. You know that loss of electron is oxidation. Loss of electron is oxidation and gain of electron is reduction. You know that, right?
Yes, sir.
Gain of electron, oxidation. Sorry, reduction. Gain of electron, reduction. Now there is a very simple question. When zinc rod from the left started oxidizing itself, that means it is breaking down into Zn plus 2 and goes into the solution. So what is the scenario? Means after some time, this zinc rod will be thinner, and after some time, this copper rod will be thicker. As you know that copper from the solution goes and stick to the copper rod, so it becomes thicker with the time, and zinc will become thinner. Is that clear? This is very easy to understand, right?
Yes.
Now see what happens. So one thing is clear, that left hand side we have from this word we usually remember this: L for left, O for oxidation. That means on the left hand side you will have oxidation. A for anode, and anode is negatively charged. Anode is negatively charged. Till now, if you have studied electrolytic cell or electrolytic solution, you have seen that cathode means negative electrode and anode means positive electron. But here in electrochemical cell, you can see zinc is oxidizing itself into Zn plus 2 and leaves some electron in the rod, and that's why the rod becomes the rod becomes negative because electron carries negative charge. So that's why from lone you can remember this, that left oxidation, anode negatively charged. On the same way you can go for this RRCP. That means R for right, and then again R for reduction, C for cathode, and it is P for positive charge. Just opposite to that. You can remember only lone. L is left, so opposite of left is R. That means right. O is oxidation, opposite of this is reduction. A is anode, opposite of anode is cathode, and is negative, opposite of negative is positive. Is that clear?
Yes, sir.
Now move to the next point. Now there are some importance of this salt bridge as well. Very important role. First of all, I'm going to show you again. Just wait a minute. If you have understood the point, I'm just again going to take this. Just wait a minute. You know, current will flow till there will be difference in potential. If the potential will be same, then the current will not flow. Now see, again I have taken this. Now what happens? Initially ZnSO4 is there. So when you are going to dissociate it, it will be converted into Zn plus 2 plus SO4 minus 2. That means, let's say this is, if you have taken one molarity of this, so in the solution, there will be one molarity of Zn plus 2 and one molarity of SO4 minus 2. That means they are electrically neutral. Yes or no?
Yes, sir.
You can see positive and negative are equal. So they are electrically neutral. But when the process started, so from this rod, you are getting extra Zn plus 2. That means Zn plus 2 concentration increases as well as charge also increases. Yes or no?
Yes, sir.
Concentration increases as well as charge also increases. So basically, there is disbalance in the solution about the charge or the now what do we say, electrically neutrality lost. So this electrically neutrality is maintained by this salt bridge, which consists of some aqueous solution or paste of KCl type solution. KCl, that means positive and this is negative. Okay, now see what happens. This is positive, positive charge increases here, positive charge increases here. So in order to neutralize this positivity, this Cl minus negative will start moving towards the positive and it will start neutralizing the solution. Is that clear?
Yes, sir.
In the same way, if you are going for this CuSO4, CuSO4 is going to dissociate into two parts, Cu plus 2 plus SO4 minus 2. Initially, if you have taken one molarity of this will be your 1 molar and this is also your 1 mole. Okay, but when Cu plus 2 started going into the rod, going to the rod and stick to that, the concentration of Cu plus 2 decreases. Why? Because whatever is in the solution Cu plus 2 and their electrons comes from anode, this will go and stick to this. That means the concentration of Cu plus 2 decreases and also negative charges increases. Actually, negative charge does not increase, but with respect to Cu plus 2, since positive charge decreases, so we can say negative charge increases, yes or no?
Yes, sir.
So in order to neutralize this positive will come into play and goes and start neutralizing the solution. One more thing which is very important, the speed of this cation or anion, speed of K plus, I'm going to write, that means cation, will be almost equal to speed of anion. This question has been asked. Okay, anion, that means Cl minus. Is that clear?
Yes, sir.
There are some conditions to use KCl. You cannot use KCl when you have silver electrode because it reacts with silver and make a PPT. So generally we use KNO3 and all. Okay. So there are some not disadvantages. Basically, there are some conditions for this salt bridge. Okay. Now,
Yes.
do you know how to represent?
Sir,
Step?
at last, can you show me, like from the first, I'll take a screenshot because in first I was not there. And now also it's breaking, sir. I have to take a screenshot, sir.
Okay, just wait a minute. Yeah, I'm just giving. Do you want me to show this?
Okay, sir, down. Yes,
Well,
sir, down. Yes, sir. Sir, little bit up.
just wait a minute. Is this you want to?
Yes, sir. Yes, sir, down. Yes, sir, down.
Is this? You know.
Yes. Yes, sir. Thank you so much.
So this was about Daniel's cell. Do you know how to represent a cell, or from representation how you are going to write reaction? So basically, you know that on the left hand side, I'm going to write it here. On the left hand side, oxidation took place. So basically, Zn converted into Zn plus 2 electron. And on the right hand side, Cu plus 2 reduce itself by gaining 2 electron and it will be Cu solid. Okay, this is your solid. Whenever it is in aqueous solution, whenever it is in ionic form, that means aqueous solution and solid. So this is called oxidation half reaction and this is called a reduction half reaction. Okay, now see what will happen. If you want to write the redox reaction, you need to add this as well as add this. So basically what I'm going to do, 1 plus 2. So left will be added in left, left will be added in left, and right will be added in right. Right will be added in right. So you can see the electrons should be equal. If electrons are not equal, you have to make it equal. Like if you have got 1 electron here and 2 electron here, So what you need to do, if 2 electron is there, you are going to multiply this equation with 2, and if you got 1 electron here, you are going to multiply this with 1. If the electrons are not equal, you have to make it equal. So you are going to cancel this, because in the reaction, final reaction, you should not have any electron. You haven't seen that, right? Zn plus 2 plus Cu. This is the complete reaction. And if someone is going to ask me how you are going to represent this, this is a chemical reaction, how you are going to represent it. Can you write the representation of this cell?
Yes, sir.
Yes.
It will be Zn slash
Yes.
Zn plus 2.
Very good.
And then 2 lines, bridges.
Two double,
And then,
double slash.
yeah, double slashes, and then Cu plus 2, and then Cu.
Very good. So basically very easy. As I told you, UPSC suggested that on the left hand side, oxidation should be there. So which one is going to oxidize? Can anyone tell me what is the oxidation of state of zinc here? What is the oxidation state of zinc here? Both of you.
Sir, it's in solid state, sir.
Yeah, solid state. So what will be the oxidation state? See, whenever you have an
It's
element,
Zero,
one.
sir. For pure
yes,
compound,
yes,
it's zero.
very good. Elemental form or molecular form, not compound, molecular form, the oxidation state will be 0. This is your elemental form, molecular state 0. So it goes from 0 to plus 2, that means oxidation took place, and this goes to plus 2 to 0. Since it is also in elemental form 0 it is. So plus 2 to 0, this is your reduction. So basically, oxidation we are going to write first. So between two elements like same oxidize, this is your Zn going into Zn plus 2. So there will be one slash. You can write solid as well as here aqueous. And also you can determine the molarity. And double slash is for, this is for salt bridge. We write this for salt bridge. Okay, then go for the reduction going from Cu plus 2 aqueous. If concentration is given, that you can write slash Cu in solid. Is that clear, both of you?
Yes, sir.
And in the same way, you can write the reaction for this what do we say, representation. Like for this, it is oxidizing, so Zn is going into Zn plus 2. You can write, that means 2 electron is there, and this is Cu plus 2, which is going in Cu. So plus 2 to 0, how it will go? When it will gain electron, and then add it, electrons are equal, this will be cancelled, and you will get your answer. So I want you to write the cell reaction for this.
So can you please repeat the last point?
You need to write the cell reaction for this cell representation.
Yes.
What will be the cell reaction for this?
So can I see it?
You can tell me the reaction if you have done.
Yes, sir. So Cr plus Pb plus 2
Yes.
will give us Cr plus 3, Cr plus 3 plus
Yes.
Pb.
Okay, can you check the charges? Is it balanced or not? Because I told you, if you are going to see this reaction, if you are going to add this reaction, Zn plus Cu plus 2, that is giving you Zn plus 2 plus Cu. If you are going to see, this is a balanced chemical equation. Either you are going to check the charge or either you are going to check the atom. That means
Sir, you're not audible. You're not audible.
am I audible now?
You're audible, sir. I can hear you.
No problem. So what I was saying is that the you can see the atoms are balanced here. Atoms are balanced. But if you are going to have, if you are going to check the charge, on the left hand side 0 plus 2, total charge is plus 2. On the right hand side plus 3, 0. That means 3 charges which are not equal. That means the reaction that you have done is not correct. Okay. It should
Sir,
be
so we
balanced.
need to we need to find the number of electron, and we need
Yeah,
to
basically you
find
need to do in stepwise. Like on the first step, this is your left. That means oxidation is taking place. So Cr is going into Cr plus 3 electrons. Since it is going from 0 to plus 3, that means it lost 3 electrons. And on the right hand side, you can see Pb plus 2 converting itself into Pb. That means plus 2 to 0. That means it gained 2 electrons. So when you are going to add this, there will be electron that is left. So in this case, I told you when you have not equal number of electron, you are going to multiply this with 2 and you are going to multiply this with 3. The number of electron opposite. Okay, cross.
6, sir.
Okay, cross you are going to do it and write a new equation like 2Cr is going to, this 2 will be multiplied in the whole equation. So it becomes 2Cr plus 3 and 6 electron here. And here the 3 will be multiplied in the whole equation. So 3Pb plus 2 plus 3 to the 6 electron. And you can see 3Pb is there. Now when you are going to add it, you can see the number of electrons are equal and they will be cancelled and you will be getting 2Cr. Just wait a minute. You will be getting 2Cr plus 3Pb plus 2. That will be giving you 2Cr plus 3 plus 3Pb. So now if you are going to check the atoms, 2 chromium, 3Pb, 3Pb. If you are going to check the charge, there is 0 and there is plus 2. Plus 2 into 3, plus 6. There is 2 plus 2 into 3, that is plus 6. And there is 0. So charge also balanced and atom also balanced. Always, when you are going to learn something, don't do it in shortcut. First, you are going to write it step by step, and then you can use the shortcut. Okay?
Yes, sir.
Yes.
Okay. Also, if you have done this, that is also correct. Not correct, basically. You can do this in this step as well. Whatever charge here, you are going to multiply it. Where you are going to multiply it? On the, wait a minute. On the right hand side, like 2 Pb plus 2 you have. So you are going to multiply this 2 and plus 3 charges here. So you are going to multiply here. And accordingly, you can balance the atom. Like what I want to say is that you had given me this, right? Cr plus Pb plus 2. That is going to give you Cr plus 3 plus Pb. So what I told you to do, whatever is the charge here, you are going to multiply here. And whatever your charge is here, you are going to multiply here. Oh, just wait a minute. Opposite. Like this, 3. And then you can balance it. 3Pb is there. So 3, 2 Cr is there. So 2. So it is balanced now. Okay. Is that clear?
Yes, sir.
Let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. Now see. So you know how to calculate E naught cell, right? E naught cell is equal to E naught cathode minus E naught anode, or we write E naught right minus E naught left. Basically, always remember that whenever we are going to write the value cathode, we write reduction potential, or anode, we write the reduction potential. That means we write the value of reduction potential, not oxidation potential. Why I'm saying that? Because at anode, oxidation takes place, and generally oxidation potential value is given. So you have to convert that into reduction potential by just changing the sign. I'm just going to give you a question on that. Just wait. Hmm. Calculate. E naught cell of following. Yeah, here it is. Fe solid slash Fe plus aqueous. That is going in Cu plus 2 slash Cu solid, and this is your aqueous. Here it is given that E naught Fe slash Fe plus 2 is equal to 0.44 volt, and this is given as Cu plus 2 slash Cu is equal to 0.34. Right? Let me know.
Sir, a question. So 0.44 volt will become minus 0.44 volt. Excuse me, sir.
Just wait a minute. Wait a minute.
Yes.
Yes, Rajita. Did you send this message?
Sir, is the answer minus 0.10?
Who is this? Rajita, are you saying
Rajita.
0.9? Rajita, okay. No, see, E naught cell, I gave you this formula. You already know.
Yes, sir.
Cathode minus anode, what is the value of cathode, or right in the representation, what is on the right hand side? This, right?
Yes, sir.
And the value of E naught is given of what? Like E naught oxidation potential, because you know that electrode potential is of two types: oxidation potential and reduction potential. Okay, and they will be equal in for a particular reaction. They will be equal. Okay, only the sign changes. So basically, according to IUPAC, electrode potential is equal to reduction potential, and electrode potential is equal to minus of oxidation potential, or you can write reduction potential is equal to minus of oxidation potential. Okay, now if you are going to see you have to check the value. What is the value given? +2 to 0. That means this is the reduction potential. That is good. Okay. On the left hand side, you are going to check this is reduction. Okay. Check the value. That is important. This is the value of 0 to +2. That means this is the value of oxidation potential. But to calculate E0 cell or electrode potential of any cell, you need to have reduction potential. So in order to get reduction potential, that means Fe plus 2 slash Fe, you are reversing. So we have oxidation potential value 0.44 plus 0.44. So you are going to make it minus 0.444. Are you getting my point?
Yes, sir.
Now E0 cell will be equal to right minus left. What is on the right hand side? First you need to check it. We already checked it. We have 0.34. Okay, minus 0.44. So what we will have 0.34 minus plus 0.44. So we will have 0.78, right?
Yes, sir.
So this is the value of E0 cell.
Yes.
Okay. So this is always remember when you are going to put the value should be of reduction potential. So always check the value of what it is given. Generally, a student don't check. So it is oxidation potential, but we need to put the value of reduction potential. And it's not tough to calculate reduction potential. You just need to change the sign. Okay.
Yes, sir.
Okay. Can we move to the next part?
So can I copy this?
Yes, yes. Pia, the answer that you had given is wrong, right?
Yes, sir. I did 0.34 minus 0.44. I
Yes,
got
that's
minus
what
0.
I'm trying to explain that
Yes, sir.
whether it
Understood.
is at anode or cathode, you are going to put the value of reduction potential.
Yes, sir.
So you
Let
can
me know when
change it.
Did anyone say anything?
Sir, I finished writing. That's what I said.
Okay. Please do write it and let me know when you are done with this.
Sir, actually 7:30 our physics class will start for NEET.
Okay, so 7:30, is it 7:30 there?
Yes, sir. 7:30 exactly.
Okay, so we may join that class. Okay.
Yes, sir. Yes, sir. Done.
Very good. Now see, I'm going to give you this ECS electrochemical series, which is very important. If you're going to see in ECS electrochemical series, in NCERT, fluorine is on the top. I'm going to write from bottom. Lithium is the most negative, and then decreases. Basically, the value, if you are going to see the value, it will decrease. But if I'm going to ask you -3 or -2, which one is
-2, sir.
-2 is a bigger number than -3, right? So
Yes,
basically,
sir.
most negative value, let's say it is -3.45 something volt, and it decreases up to hydrogen, which has E0 value of 0, and then increases up to fluorine, which has most positive value, most positive. Now see, this is the value of E0 R reduction potential. Okay, E0 R reduction potential. Always remember that when it is E0 R is directly proportional to oxidizing power. That means it is a very good oxidizing agent. That means fluorine is the most oxidizing agent, most strong oxidizing agent, And the one which is having lowest value will be the most reducing agent, That means E0 R is inversely proportional to reducing power. Okay, and there are a lot of questions that has been asked. If I'm going to ask you a very simple question, x is equal to -1.5 volt and y is equal to 2.5 volt and z is equal to 2 volt, and I will say arrange this in increasing or decreasing order of reducing power. Decreasing order of reducing power.
It will be X, Y, Z.
X and then
Y. No, sorry, X and then Z and then Y.
because the lowest value is this, so it will be the most
Yes, sir.
reducing, and then comes your Z and then comes your Y. If they will ask you the most oxidizing power, the value which is the greatest. Okay, so I would like to give some question of NEET from this. Just wait a minute.
Sir, I was wondering, is there any way you can send me important questions from this chapter for revision?
For what? Okay, for board or NEET?
Uh, for any, sir, anything that you feel like is important to know from this chapter,
Okay, I'll send it to you.
or
This
commonly asked
weekend,
questions. Yes, sir.
this weekend I will send you. Like on Sunday, I will send you.
Okay, sir.
We'll
Yes,
go
sir.
through that. Do you have maths or bio?
Biology, sir. Biology.
Please do this question. That question has been asked in NEET and this question as well.
There is the answer C.
Which one? 47.
Yes, sir.
Yeah, very good. Who gave the answer? Sia or Razita?
Rajita.
Okay. Go for the next. This कुछ student present में मैं ऊपर पीने से अभी डॉक्टर हैं कम से कम गवर्नमेंट स्कूल गवर्नमेंट और कॉलेज ये सारे मैडम मुझे आज तक देखो मैं जो करता हूँ सामने करता हूँ अगर मुझे छुपाना हो तो सेपरेट भी छुपा लेता हूँ तो मैं पीता था कभी कभी पहले जब कॉलेज में था ना तब मतलब उस टाइम पे दिल्ली में थोड़ा ठीक है सर तो मतलब दिल नहीं करता तुम भी पीते हो
Sir, option C again.
Option C again. Priya, Priya, option A for which question? 47 or 36?
36, sir.
Yes, sir. Okay, reducing power. The most reducing power is for inversely proportional. This is the lowest value, so Z, then comes your X, and then comes your Y. So the option C is the correct answer. Are you done with this? Yeah, have you got it? Any answer for question number
Yes,
47?
sir. Is it it's based on the number?
Yeah, I told you that this is the value of electrode potential, right? A standard electrode potential. So I told you E naught is directly proportional to oxidizing power and E naught inversely proportional to reducing power. Okay.
Yes. Yes, sir.
Okay, there is a Nernst equation that is very important. Nernst equation. Nernst equation is like this: E cell, that means electrode potential of cell, is equal to E naught cell, that means a standard electrode potential of the cell, minus 0.059 upon N, log of product upon reactant. And this log of product upon reactant we are going to take only for aqueous or gaseous state. And N is the number of electron transferred. Number of electron transferred. That means if the reaction is given, or you can write the reaction like we had Zn plus Cu plus 2, that gave us Zn plus 2 plus Cu. So you can see in this what happens, 0 to plus 2 it is going. So the number of N for this reaction will be 2. You are not going to take 4 like 0 to plus 2 and plus 2 to 0. Basically the number of gained by one of the system will be lost, was lost by someone. So number of electron will be equal to 2. This is how we take the number of electrons. Is that clear? Oh, is that clear? Am I audible
Sir,
to?
no, sir, can you repeat again?
I'm gonna write. So this is the Nernst equation, right? And if you have
Yes.
reaction directly given, or you can write the reaction. And if I'm gonna ask you, what is the number of electron in this? So number of electron transferred, that means number of electron total lost or gained. You are going to take only one of them because number of electron lost will be gained by someone. So either you are going to take lost or gained. So you can see lost by this zinc is 2, so the N will be equal to 2. Is that clear?
Yes.
So if I'm going to give you Cr plus Pv plus 2 will be equal to Cr plus 3 plus 3 Pv. Can you tell me the number of electron lost or gained?
Sir, is it 6?
Exactly. Because you can see from 0 to plus 3. And how many atoms are there? For one atom, it is 3. So for two atom, it is 6. So N will be equal to 6. Just wait a minute. Okay, I'm going to give you a question. Can I change the slide?
Yes, sir.
Okay. Write the question. Find EMF of cell. Find EMF of cell. And the representation is given like Mg/Mg, double Mg plus 2, that is in aqueous solution, and it has a concentration 0.1 m. Double slash Ag plus aqueous solution, and it has a concentration 0.01 m slash Ag in solid. And here it is given that E naught cell is equal to 3.17 volt. Please do this. If you don't understand, just let me, I will explain. Will you be able to solve this? So in the next class, what you are going to do? Aldehydes you have completed or not? Rajita and Fia are not audible.
Yes, sir.
So you're asking in Kannapat.
I was asking aldehyde and ketones, have you completed?
So like in Learnivio, in tuition or school? Yes, sir, we completed all that.
Okay, aldehydes and ketones you are going to do MOP and chemical reaction. In the next class, we are going to do questions on this. If you have 1 minute, I think you can do this. Okay.
Yes, sir.
Okay. Should I explain this?
Yes, sir. I was doing, but I got stuck.
Okay.
In
The
between.
EMF of cell, if you are going to calculate, each cell you are going to apply. Each cell has
We have to first balance the cells, sir. So
0.0
we need to
0.059 log of product upon reactant. First, I wrote the formula, and for product and reactant, we need to write a equation. So what I told you, this is oxidation. So Mg is going from Mg to Mg plus 2. That is 2 electron lost. And Ag plus is going into Ag. That means 1 electron it gained. Now you can see electrons are basically not equal. So I'm going to multiply this by 1 because there is 1 electron. And I'm going to multiply this equation by 2 because there is 2 electron. And add this simultaneously I'm going to do. So if you are going to multiply this by 2, 1, so it will be Mg. And if you are going to multiply this by 2, it becomes 2Ag plus. And this 2 electron. And on the right hand side, you can see there will be Mg plus 2 plus 2 electron is already given multiplied by 1 plus 2Ag. Is that clear? I did simultaneously. Pia, is that clear? You are not audible.
Yes, sir. Yes, sir. It's clear.
Okay, so Mg in solid react with 2Ag plus. That is going to give you Mg plus 2 in aqueous and plus 2Ag. So reaction is balanced. First of all, you are going to calculate number of electrons. So you can see Mg is in elemental form 0 oxidation state to plus 2. So N will be equal to 2. Or you can calculate from this plus 1 to 0. That means 1 for 1 atom, the number of electron is 1 transferred. So for 2 atom, it will be 2. So n is equal to 2, you count it, right? Now you are going to put the value in the formula and you will get your answer. E cell will
Yes,
be
sir.
equal to
I
E
did
naught
till
cell.
here it's correct. But for the
Okay,
product,
just wait
which
a minute.
product I have to put?
Just wait a minute. 3.17 minus 0.059 divided by number of electron transferred, that is equal to 2. Log of product. For product, we are going to consider only gas and aqueous, like you did in a chemical equilibrium, right? So product is your this Mg plus 2. So Mg plus 2, concentration of Mg plus 2 divided by concentration of reactant, that is Ag plus. And in chemical equilibrium, what we do is whatever is the concentration raised to the power there is stoichiometric coefficient. So you are going to put 2 here. And according to the representation, if you will see, there is concentration of Mg plus 2, that is your 0.1. So you can take 10 raised to the power minus 1 here. And this is 0.01. That means 10 raised to the power minus 2 raised to the power 2. And you can easily calculate it. E cell value. Can you do this?
Yes, sir.
Okay, so is it for today? I'll see you in the next class. Okay, please be prepared for this MOP of MOP and chemical.